Okay, in this video, this is Einthoven's triangle. We're obviously going to look at Einthoven's triangle and why it's important and how it's going to help us interpreting the ECG. Now, up until now, we've only looked at the ECG from one standpoint. So I'm going to draw a person here, um, and it'll just be their chest. Because normally, when you're doing an ECG on somebody, especially if it's a stress test, what we do is we place the electrodes only on their chest. So I'm going to place these electrodes here. Now these are the electrodes we are typically looking at, and so we would draw the heart like this, and this is what we've been doing in previous videos. But this is only one view of the heart. This is only one of the many leads, or the 12 leads actually, that we can look at the electrical activity of the heart. And so Einthoven's triangle is going to kind of help us look at the heart in some other ways that'll improve our interpretation of the ECG. Because just looking at it from one lead isn't going to give you all the information you need. So we still have our heart. It's still depolarizing from the SA node, and you're getting that very large atrial depolarization. It goes to the AV node, the bundle hist, the bundle branches, the Purkinje fibers, depolarizing that ventricle in this direction. You know what? I'm even going to change the color here real quick to make this a little bit more obvious. So here's our atrial depolarization, and then here's our very large ventricular depolarization. I'll go from to green. So when you actually are going to do an ECG on somebody, there are other electrodes. Okay, there's electrodes, obviously, so we have an electrode here. This is the right arm. So it's really just a patch. It doesn't really have a sign on it. And then there's one down here on the left, toward the left leg, but it's actually on the person. And then this one's, we'll call it right leg. And then we'll put one up here that we'll call left arm. All right, so we have 4 electrodes right now on the front of this individual. So what we're looking at here, because the electrodes are on the limbs, the arms and legs, we're going to look at different leads or different views of the heart. So here's our limb leads. Our limb leads are leads 1, lead 2, and lead 3, our basic 3 limb leads. And because we have the electrodes not actually on the arms or legs, but on the torso, we call this the Mason-Likar placement of the electrodes. And this is the placement you use when you do a stress test, because if these electrodes were actually on the arms and legs, the wires would be flow everywhere as they're trying to run, and it wouldn't really work out very well. So let's look at what's the difference between lead 1, lead 2, and lead 3. What are we actually talking about? Well, let's start with lead 2, because lead 2 is the most common. If you were just to look at one single lead, you would probably look at lead 2. So in lead 2, we're going to take the electrode at the right arm, and we're going to assign it a negative sign here. And the left leg down here, we're going to give it a positive sign. So this is what we've been doing up until now already. So when we go from the right arm to the left leg like this, if we are looking at the electrical activity of the heart in this direction, from negative to positive, from right arm to left arm, we call that lead 2. So this is lead 2. And so you'll recognize when we look at the QRS complex, if we look at the whole cardiac cycle in lead 2, this P wave activity, if you look at that arrow, is it going towards the negative? No, it's going towards the positive, but it's not a lot of tissue, so that's when we got that upright P wave. And this large electrical activity in the ventricles is going towards this positive at the left leg, so it's got a very large QRS complex, and then we had a T wave. So we've always been looking at lead 2 in the previous videos. But now let's say we want to look at, well, what if we used a negative at the right arm and a positive at the left arm? So now we're looking at the activity as it goes from right to left, straight across. And we call this lead 1. So the question is, if we looked at lead 1, what would the ECG look like in lead 1? So you just have to look at the heart and look at the depolarization and ask yourself, is atrial depolarization going towards the right arm, which is negative, or towards the left arm, which is positive? Well, it's going more towards the left arm. But the other thing you want to note is that arrow is kind of going down, which is a little bit away from the positive. It's definitely not towards the negative right arm. So this is going to be an upright wave. It just won't be as large as it might be in lead 2. So in lead 1, the QRS complex would have a P wave, but maybe it's just not as big. Now what about the QRS complex? Is this arrow going towards the right arm or towards the left arm? And you have to make a choice. Well, it's going towards the left. It's not directly going towards the left arm, but it is going left. It's definitely not going towards the right. So the QRS complex will be upright. But since it's not going directly towards the left arm, it's going down, it's not going to be very big. So our QRS complex will be smaller than it was in lead 2. And likewise, the T wave will probably also be smaller. And let's say we want to look at it in one more lead, and that is with the left arm being negative and the left leg being positive. So we're going to look at the heart as it goes from the left arm to the left leg in this direction. So this is what we call lead 3. So here is lead 3, from left arm to left leg. So in lead 3, the question is, I wonder what the ECG looks like in lead 3. Well, let's take a look. So in lead 3, the left arm is negative and the left leg is positive. So the P wave, this atrial depolarization that's occurring, is it going towards the negative left arm or is it going towards the positive left leg? Well, it's going down. I'd say it's going towards the left leg. So this will probably be a decent P wave, almost like lead 2. And if we look at the ventricle, it's very large, going towards the left leg, away from the left arm. So you'll have a decent sized QRS complex and then a T wave. So leads 3 and 2 in this situation look fairly similar, but if you look at lead 1, everything is much smaller. And now you know why, because when you look at lead 1, you know the negative electrode was the right arm and the positive electrode was the left arm. And so the depolarizations were going toward the left, but not directly toward the arm. They were actually going more downward toward the leg. And so that means it's smaller electrical activity. Now, we don't have to stop there. Just by placing these 3 electrodes, we can get 3 more views. Now, these initial 3 were called the limb leads. But what we're going to do now is we're going to take those limb leads and we're going to change them up just a bit. Now in this scenario, we're going to start at the middle here. So we're going to start at the middle of this triangle, which is right here. And then we're going to go towards each electrode. Now what you might be wondering is, why don't we ever use this right leg electrode? And I may not have mentioned it, but this is just a ground lead. Like in a lot of electrical situations, you need a ground lead for everything. So that's what the right leg is. So let's start in the middle and let's go towards each corner of this triangle. And so if we start in the middle and we're going towards the right arm, in this case now, the right arm serves as a positive electrode for us. And so we call these augmented limb leads, and this is augmented VR. R stands for right arm. So now we're looking at the augmented limb leads, and the first one we have is AVR. Now, if we're going towards the left arm, and that's going to be our positive electrode, then that is AVL. AVL. And the last one is what we call AVF. So we go in towards the left leg, or the foot. So the positive electrode will be here. We'll call this AVF. So the middle would be considered the negative, and then each of the corners are considered the positive for these 3 electrodes. So we won't look at AVL, AVF. I mean, if you look at AVF here, it's going straight down towards the left leg, similar to 2 and 3. You can guess that the ECG and AVF is going to be very similar to 2 and 3, and it is. 2, 3, and AVF all usually look very much alike. Let's take a look at AVR. It's a nice one to look at. So AVR, we're going towards the right arm. So what does this ECG look like in AVR? So in AVR, what's our QRS and T look like? Well, let's start with our P, our atrial depolarization. The question is, so is our depolarization here going towards the positive electrode of AVR? And it's clearly going the opposite direction. It's going away from the right arm. So in AVR, the P wave is going to be negative because it's going toward the negative or away from the positive. It's going directly away, so it's going to be a decent-sized P wave. Well, what about the QRS complex, the ventricular depolarization? Well, it's going almost directly away from the right arm. Okay, so this is going to be a very large negative QRS complex. And you'll probably have a negative T wave. So what do you notice about AVR? AVR, going towards the right arm, is pretty much directly the opposite of leads 2 in AVF. And so if this is what the ECG looks like in lead 2, well, then it makes sense that AVR is probably just the complete negative. It's the opposite of lead 2. Everything's upside down. So what you can do is, now that you have an idea of Einthoven's triangle and you know the normal depolarization of the heart, you can pretty much draw out what the ECG looks like in 3 different leads. 1, 2, 3, AVR, AVL, and AVF. Whoops. Did not mean to do that. Okay. So that's Einthoven's triangle. And I will draw it one more time just so that it's a little bit more clear. You have the electrodes at the right arm, the left arm, and the left leg. We can look at it in these 3 general directions. That's lead 1, where it's negative at the right arm and positive at the left arm. Lead 3, where it's negative at the left arm, positive at the left leg. And lead 2, the most common, negative at the right arm, positive at the left leg. And we can also go from the middle to the left arm. That is AVL, and this would be positive. From the middle to the foot, or the left leg electrode, there would be positive. That is AVF. And from the middle to the right arm, which would be positive, and that is AVR. So that's Einthoven's triangle.